So part 2 of our lesson on nonlinear solving is going to be pretty brief. The goals of this section are to practice solving quadratics through factoring, to use the built-in calculator to solve quadratics when factoring is difficult, and then the new information that is in this part of the practice is to use the discriminant to determine the number of solutions in a quadratic, and to solve questions related to exponential growth and decay. Finally, we will practice working with exponents and roots a bit more. So we've talked about number of solutions in linear solving as we identified them from equations with a single variable and a constant. Here we are using a quadratic in the standard form, ax squared plus bx plus c, where a, b, and c are real numbers. The discriminant is d is equal to b squared minus 4ac. This is something that is going to be new to practice and will help us anytime we need to find the number of solutions from a quadratic equation. So if the discriminant is positive, the quadratic has two real solutions. If the discriminant equals 0, the quadratic has one real solution. And if the discriminant is negative, the quadratic has no real solutions. Above, you will see the quadratic formula. X is equal to negative b plus or minus the square root of b squared minus 4ac over 2a. It is worth noting that the discriminant is everything we see under the square root symbol. In example number 4, we will practice finding the number of solutions given a system of equations where one of the formulas is a quadratic formula. And our final piece of new information is on growth and decay. Exponential growth or decay formulas can be applied to real-life situations as well as the SAT. When the growth is a percent of the total population, you will use the final amount is equal to the original amount times 1 plus or minus the rate to the power of the number of changes. When the growth is a multiple of the population, use the final amount, set that equal to the original amount times the multiplier, and raise that to the number of changes. In example number 8, we read, a couple buys a certain home that is worth $120,000. A real estate agent tells the couple that the value of the home will increase by 12% per year for the next 10 years. The real estate agent uses the equation H is equal to 120,000 times K to the power of Y to model the value H of the home after Y years. What value should the real estate agent use for it? For K. So using the exponential growth or decay formulas, we will determine the value that we would plug into the parentheses. Well, that is all the information that I have for you on Nonlinear Solving 101 and Nonlinear Solving. If you have any questions about the lesson today, please ask your math teacher after writing them down. Enjoy your practicing and have a wonderful fall break.